Hello friends, this is AKHILESH Pandeey and in the last lecture we had learned in network analysis about the voltage, about the current and about the charge. Now in this lecture I am continuing the same topic, the basic concept, and this is lecture 2, and so here I am going to start the power. Power, of course, dealing with the network analysis means electrical, so of course power deals with the electric power. Okay, now power is what? Power, we all know that the rate of doing work is called power. Okay, rate of doing work. Now rate of doing work can be defined in a mathematical form like this: P equals to dW upon dt, where W denotes what? The work done, and of course T is time. So whatever the work is being done by any voltage source, of course we are dealing with the networks, so we are dealing with only electrics. Okay, the work done by any voltage source or by any current source or by any other source or sources, the rate of doing work will be called power. So further we can derive it in the terms of voltage source and current source. How we can derive? So we are doing a small trick here: dW upon dq, dq upon dt, dividing by same and multiplying by the same value. Okay, now this we know. What is this? This is voltage. Voltage is what? Work done per unit charge to bring up charge from some point to some other point is the potential difference, and further we derive that as voltage. Similarly, the work done per unit charge will be voltage. Again, dq by dt, charge per unit time flowing through any cross section will be called the current. So current is dq upon dt, and here we can have V into I, voltage into current, very important. Okay, power equals to, now we have the relation V into I. So power is nothing but the multiplication of the voltage and the current, whatever it is, either it is instantaneous power or it is average power. Similarly, we will take instantaneous power, voltage instantaneous, current instantaneous; average power, voltage average, current average. Similarly, okay, this relation will stand for everything, either it is about DC, it is about AC. We will see it later, but from the basic point of view, this is the main fundamental definition of a power, and power is derived as very important, means voltage and current multiple. Okay, so power is done. Now we used to say that here the voltage source is absorbing power, here is some element is supplying power. So how we can determine whether an element, a given element or a source is supplying power or it is absorbing power? So this is our next topic. Let's see. So I am taking just four types of arrangements, and then after you will come to know very easily whether it is supplying or it is absorbing power. Okay, here we have this arrangement. Again, I am taking the direction of the current in the opposite one, and now I am taking a current source and voltage I am considering here across it, plus minus V. Again changing the direction of current with the same voltage across it, plus minus V. Okay, if we consider it I, this one is voltage V, this is I, this is voltage V, and this current I. So as just we derived the formula of power, and that is P equals to VI. Okay, VI will be the same, the quantity will be the same for all. Now what we have to decide? We have to decide only the two things: whether it is absorbing power or it is supplying power. Okay, supplying, sometimes it is written as delivering, and so on. So whether it is supplying power or delivering power, or it is absorbing power. Okay, now in this circuit we can see, okay, a voltage source is what? Voltage source, from a voltage source we know that current comes out from the positive side, from a voltage source which is supplying power. we all know that current comes out of the positive side, then it is supplying power. Okay, here we can see that at positive side the current is entering, so it will be considered as absorbing power. Instead of it considering it as a source, it will be a passive element. We will discuss later, but here if at positive tip, at positive point the current is entering, this will be called absorbing. Here what it is, at the negative end current is entering, means from the positive side current is exiting. We have to just think either about entering or about exiting. Okay, here at positive side current is entering and exiting from which side? From negative side. So if current is entering at positive side, this is absorbing, or in other way we can think like this one as well, like if any current source is exiting from the negative side, we all know that the conventionally if a voltage source is supplying power, it means from positive side current is supplied and negative side current is entering. This is the conventional if it is supplying power, but here is the case, reverse case, and we can see that at positive side current is entering, so it means it is absorbing power. This is the case where at positive side current is exiting and negative side it is entering. Similarly, so we can say that here what it is supplying power. Again, what we have here, from the positive side, this is the current direction, from the positive side current is entering at positive side, so it will be absorbing again. Now what about it? Again we can see from the positive side current is exiting, and from positive side we are supplying current. This is the case of supplying voltage source. We must be in our mind that for the supplying voltage source, this is the case only, that from positive side current is given, current is supplied, then it is supplying. From positive side no current is supplying, instead it is taken, so it is absorbing. From positive side current is supplying, so it is supplying. From positive side current is taken, so it is absorbing. From positive side current is supplying, so it is supplying. So overall we can see that this is the arrangement of supplying power and absorbing power. I don't think that there will be any confusion about it. Now the confusion, where can be the confusion point? Okay, so the confusion point can be like this. If here we have the current and it is written as minus 2 ampere, okay, and again the voltage source is like this, plus minus 5 volt. I am taking an example. So in this case, first of all, if you will be asked that what is the power, so power we can directly give as like this, 5 into 2, it means 10 watt. Now the point is whether it is supplying power or it is absorbing power. Okay, first of all we can do what? Minus we can omit. How we can omit? So for omitting minus, we will have to reverse the direction of the current. Okay, if we omit minus, means minus 2 ampere flowing in this direction, it means 2 ampere is flowing in the opposite direction. So if we omit minus, so we will have to change this direction, so we will do in this way. Now from positive side the current is being supplied, so it is a supplying power. Now other way to think about this question, we had this arrangement, minus 2 ampere plus minus 5 volt. Okay, now this is current, this is voltage, power we know. What is our task? We have to check the current direction. Here we can see that current is entering at positive side, so absorbing. How much? We have not omitted the minus, it means we will multiply this with the minus sign itself. So minus 2 into 5 equals to minus 10 watt. Okay, minus 10 watt absorbing, it means minus 10 watt absorbing, it means minus, it means opposite. Absorbing means if we write minus 10 watt absorbing, then it is similar as 10 watt supplying. It is like a simple thing. If we are giving you minus 10 rupees, it means I am taking 10 rupees from you. If I am taking minus 10 rupees from you, it means I am giving 10 rupees to you. Similar case, minus 10 watt absorbing, minus 10 watt absorbing, it means minus what? 10 watt supplying instead. Okay, so absorbing changes to supplying if there is a minus. That is a simple funda. So we can solve it either in this way, means omitting minus 2 by changing the direction of current and then solving it. So we get the supply, or we can directly multiply with the minus sign and checking the direction, given direction of the current source and the voltage source, and it is from the given directions. Here it is the direction and it is plus, so plus at plus side it is entering, it means absorbing, and multiplied minus 2 into 5, so the result is minus 10 watt. So minus, it means just reverse it, absorbing then supply, minus 10 watt absorbing, it means 10 watt supply. So this is the case of supplying power and absorbing power. So this is all about the power. Now we come to the next topic, and that is related to the classification of elements. Very very important topic for GATE exam point of view as well as engineering services point of view. So here the point is classification of elements. So elements, we all know that resistance, capacitance, diodes, BJT, so many elements used in electrical and electronics. So how we can classify those elements? So there are different techniques to classify them. So I'm starting one by one. Classification of elements. Okay. So first classification is related to active and passive elements. Okay. Clear from this line? Passive, which is taking power, which is not able to supply the power, will be passive. Active means which can be used to supply the power, means that can generate the power, is active element. Means if some guy is active, it means he will do something for the society. Some guy is passive, it means that is best for us. Okay, so don't be the passive one, be the active one and crack the GATE exam. Okay, now passive element is, of course, that is not generating any power, instead that is absorbing power, or it can store power as well but not generating power simply. So in passive class we have resistance, inductance and capacitance. So these are taking power from resistance, of course, absorbs power, and inductance stores power, somehow it loses something as well, and capacitance again it stores power and there is some loss. Overall these are the passive elements. Now which are in this category? So voltage source, we all know, current source, okay. Apart from it, the electronic devices in semiconductor devices, that are diode, BJT, these we can use as amplifier. So in that amplifier we can amplify the sources, amplify the given value. So in that way it can be used as the supplying power. So these are in the category of the active elements. Now come to the next classification, and next classification related to bilateral and unilateral elements. BILA. Bilateral and unilateral element. Again, clear. It is clear by its literal meaning itself. Bilateral. Bi means from the both. Okay. If any given element, either we are supplying the current through this direction, or we are supplying current from this direction, from any direction, the property of the element, if doesn't change due to the direction of applying source, due to the polarity of applying source, then that element will be called bilateral. So for the resistance, we all know whether the current is flowing this direction or this direction. If its value is 2 ohm, then it will be fixed as 2 ohm. There will be no change for whether it is the direction of current or this is the direction of current. It will be fixed as 2 ohm. Again, similar case will be for capacitance, similar case will be for the inductance. Means either we are supplying the current through this direction or this direction, the property of the elements will be same, and so in the bilateral category there will be resistance, inductance and capacitance. But in the case of semiconductor devices like diode, like BJT, we can see, means when BJT is short circuited like this. Okay, so if we supply the current through this direction, then in the forward bias the current can easily pass, but when we come to the reverse direction, the reverse bias current cannot be passed as per the property of the given diode. So this diode is unilateral, means in a single direction it has a different property, and from the other direction it has a different property. So if there is a different property for as per the given direction of the current, then that will be called the unilateral elements. And in this category, all the devices, semiconductor devices, will lie like diode, of course. And in BJT we will consider the case when collector and base side will be short circuited like this. So unilateral element is diode, bilateral element is resistance, inductance and capacitance. So this is the second classification technique. Now come to the next classification technique, and that is linear and non-linear. Okay, so what is linear and what is non-linear? Let's check. This is linear element and which is non-linear element. Linear and non-linear element. Again, clear from the given name. And linear, when the VI characteristic for a given element is linear, VI graph, if we plot current versus voltage graph for any element and that graph is linear, then that element will be called as a linear element. And if the VI characteristic, means VI graph, is non-linear somehow like this, then that will be called the non-linear element. So now we come to the properties of elements, and we will see which type of elements having the linear characteristic and which type having the non-linear characteristic. So here we do have, start with resistance, of course, and we all know that the resistance follows the Ohm's law and the very famous law V equals to IR. So we can see easily that V and I follow the simple line equation, and that's why it is a linear element. Similar case will be for the capacitance, similar case will be for the inductance, and so these will lie in the linear category. Now come to the non-linear element. Again, all the active devices, or you can say the unilateral devices as well, means diodes, BJT, these will be the non-linear elements. We will learn these formulas later in the other subjects, and that is I equals to exponential I naught exponential VA upon VT, where VA denotes the voltage across the diode. So voltage across the diode and the current through it is exponentially related. Here we can see that it is exponentially related, and the graph is used to be like this for a diode. So this is a non-linear graph for current versus voltage for a diode, and this is linear graph for resistance, inductance and capacitance. So RLC lie in this category and diode lie in this category. So this is the classification of linear and non-linear element. Now come to the last topic of, you can say the last technique to classify the elements, and that is These are the best classifications, and there may be some other classifications as well, but those are not important for GATE exam point of view. The thing that are important for GATE I have already told you. And the last one is what? Last one is distributive and lumped elements. Okay, lumped elements and distributive elements. This is nothing. Lumped elements are those elements in which R, L, C can be separated easily. For example, if we have circuit like this, resistance, here we have inductance, here we have capacitance, then the overall circuit, I am talking about the overall circuit, resistance can be separated, inductance can be separated, capacitance can be separated. So we can see easily that R, L, C can be separated easily. Then this type of elements will be called, will lie in this category, that is lumped elements. But distributive is what? Later we will discuss the transmission line in electromagnetics, and so in the transmission line what used to happen, that we have two parallel wires continuously. So what is there at for the given pair of transmission line, there is resistance per unit length. Resistance per unit length R dash defined. Okay, at per unit length there will be resistance. There will be inductance per unit length. Per unit length there will be an inductance, means like this. There will be inductance throughout. Resistance, there will be resistance throughout. Okay, and apart from it, there will be capacitance in between the parallel the two pairs. There will be the capacitance in between these two. Everywhere this will be again the per unit capacitance. Again we have, there is some conductance, means the two wires conduct some small values of current, and that its values as well, the conductance per unit length. So we having conductance per unit length in between the parallel wires, and capacitance per unit length in between the parallel wires, inductance per unit length throughout the wire, resistance per unit length throughout the wire. So if I say you that separate the resistance from this transmission line, can you do it? No. No one can do it. No one can separate the inductance from it. No one can separate capacitance from it. So it cannot be separated. If there is some element like a transmission line in which the elements, the basic elements that we have read, the resistance, inductance, capacitance cannot be separated, then that type of element will be called distributive element. So transmission line is an example of distributive element. For lumped elements, easily we can say so many examples. Resistance, of course, it's a lumped element. Inductance, capacitance, these are separated elements already. So these are the lumped elements, and this is the distributive elements. So that's all about the classification of elements, and that is all from this lecture. I am going to give you the next lecture in the next video. Thank you so much.